Yeah, this one? Okay. I was confused by some of the things up here. Let me make a couple of comments. X squared minus 1 can be factored as x minus 1 times x plus 1, right? So that's how you decide to start with, I'm going to try to rewrite this integral of 1 over x squared minus 1 dx as the integral of a over x minus 1 plus b over x plus 1, both of which will be easy integrals if I can do it, right?
So, and A and B are the variables for the answers.
That I don't know.
Right, okay.
Yeah, they're not the answer to the problem. The answer to the problem is going to be the antiderivative of this, right?
Okay.
The answer to the problem, if I take the derivative of this, I better get 1 over x squared minus 1. You wouldn't guess that looking at that, would you? You'd glance at that and say, oh yeah, the derivative of that's 1 over x squared minus 1. Probably not. But that's the answer has to be something that you take the derivative of and get back what we started with.
Right.
But to get there, this is a rational expression, and it's not a simple one that I can do. The derivative of the bottom is 2x. That's not what's on top. So it's not a simple u substitution or reverse chain rule.
So we do the partial fraction.
Right. So that's why I'm trying partial fractions. Now, once we see that, and we know that this is the form I'm going to try to get it in, I think the first thing I would write is that, right? I want to rewrite this fraction as two simple fractions. Now, how do you solve this? Multiply to get rid of the fractions, multiply both sides by x squared minus 1. What do you have on this side? You have 1. What do you have on this side? Well, if you multiply this by x squared minus 1, that's x minus 1 times x plus 1, so the x minus 1's cancel, and you have a times x plus 1.
Okay.
On this side, you multiply this by x squared minus 1, you have x minus 1, x plus 1's cancel, so you have b times x minus 1. So this is where you are now.
That x squared minus 1 kind of threw me off.
I was the same way. Yeah. He's right, you know, that is equal, because when you multiply this by this, you get that, right? Mm-hmm. And this by this, you get that, and the whole thing's equal to the numerator of this one. So he's correct.
Yeah, that's right.
And that is the disadvantage. You know, every once in a while, students explain things in a way that's, they figured it out. Yeah. That's all that matters to me. Nick can do the problem, right? But even I was going, well, wow, these equal signs, where did the one come from? Look like magic. Yeah. But you got it now. So now he knows that this is the expression he's trying to solve for a and b. And if you put x equals 1 in, you'll get a times 2 is 1. And if you put x equals negative 1, this one will disappear, and you'll have b times negative 2 equals 1. So now you've got a and b. Now you turned a hard problem into two easy problems. He does a little bit of rewriting to make it simple.
Okay. Got it. Thank you.
You're welcome. Anything else? It's on the board that doesn't make sense. Or does make sense, but we can't make sense of it. So notice this one is really the same way. And the hardest part about partial fractions is figuring out how you're going to rewrite it. But this one refactors. The bottom factor is x minus 3 times x plus 1. Then the question is, and she hinted at it, how do you decide how to break it up? Now in the notes, for the most part, I broke them up for you. I told you, here's how to break them up. But this one does break up as a over x minus 3 plus b over x plus 1. And when it gets funny is when one of these is squared or something. That really affects things and makes them more challenging. We'll get to a couple of those, but not in the next 30 seconds. Okay, so I'll answer your question. I'm going to say one more thing about 212 at the beginning of class next time, and then we'll keep rolling where we are, which is 216.